Good morning class. We are going to see a case study about failure of a helical gear. There are main number of gears, spiral gear, helical gear, main number of gears that are used in the industrial applications. But now we are going to see the failure of helical gear, right? Okay. So this is the content where what we are going to discuss. So this is we can start now.
So first, helical gear is a mechanical component which is used to transfer power from one shaft to another shaft. So the failure of gear is mainly failure analysis of helical gear is used in bus gears. So the material is AIS 8620 steel. By evaluation method, visual inspection, photographic documents and chemical analysis should be taken to know about this failure of this gears.
And what are the types of gear failures that can occur in the gear is fatigue, impact, fracture, wear, and the stress resistance and fatigue, pitting and swelling. These are the failures that can occur in a gear.
So once the failure is caused, what are the causes can be occur? Means that if the failure is occurring, what are the reasons to be mentioned? Means sort of poor design. So if helical gear is it leads to a failure, its poor design will be the primary reason. From there, the misalignment of gears. So as he said, the helical spring will be between two gears. So between the two gears, if there is any misalignment, it will be leads to a biggest cause. From there, the overloads. If gear is this much only, this weightage means apart from that we are loading high amount that. Then also, as you have said, the fatigue, the cyclic overloading. That may also leads to this. Then subsurface defects in internal stress. If a thing is incorrected, and also heat treatment also one of the reasons, the causes.
Now we are going to get into the case study of a bus gearbox. Now the major problem is occurred in the transmission of the gearbox, and then while coming into the first case, what we are seeing how the failure is occurred. The gearbox is failure due to the excessive vibrations. So, and the second one is where the failure of a gear is occurred. Likewise, we are going to see it's in the fourth gear. Now we can see in our main dice itself the major failures are here, and then this gear, helical gear, the major failures are spotted like this. There are major failures occurred, and then the parameters are normal in a gear, and then the spectrum will be.
So this is a spectrum analysis in which the result of the material is A and micro harness analysis. Okay, sir. So AISI, which is American Iron Steel Institute, which is 8620. So the core harness is 439 HV and the surface harness is 550 HV. So the core harness is low because the material is surface hardened here. Then it is the case depth is 0.63 mm, and the microstructure consists of martensite and retained austenite. Here, the white color surface which we can see in the microstructure, it is retained austenite, and the black side is the martensite, sir.
Well, coming to the visual inspections, there are failure due to fatigue failure is occurred, and then there is a triangular piece teeth had broken off. The helical gear consists of many triangular teeth. The teeth has broken off. The failure kit, now let's see, this is the failure occurred where it started, and then it's broken here. From here to this point is the broken point of this failed gear, which is in a fourth gear. The pitting is let's see in this image where the spalling is taken, and then the spalling is done, which we can see the straight lines, which is a spalling, and then the small parts which we are seeing is a destructive pitting. That's are made in the failed gear teeth.
So here I have like to add a point. This is a picture of pitched gear teeth where you can see, as a friend say, it is a pitting and spalling. This is one of the main cause of the failure.
While we have gone through major processes as SEM-TEM examinations, while in the SEM and TEM examinations we have seen that the crack initiation was started here, and then the crack was propagated. This is the cause where the gear is made a failure, and this is the major thing which is failure.
So where is the crack start area maybe?
Started area is in here.
The tip
That's
of
it.
the
Tip is okay. Moving to
Towards the outside.
outside. So this marks are nothing but the fatigue striation marks. Okay. So due to this, so with this fatigue striation marks, you can easily find from the same examination. You can easily find that this particular failure occurs majorly due to fatigue, and in added to that pitting and sparring has taken place. Okay. So
Now coming to the conclusion, which we have seen is the composition and the microstructure and the hardness of the gear are deeply, that's all satisfactory. They are at the normal level.
So the process what happened, so the pre-process means that the heat treatment or other machining process what happened is normal, it is satisfactory.
Yes. Then the factorographic features included the fatigue striations, the fatigue marks. That is the major cause for the failure of a gear. So when coming to there may be some misalignments that can make the failure. So the formation and destructive pitting and spalling, which we have seen in that image, the pitting and spalling is also one of the cause to the failure.